Excellent. Okay, thank you for inviting me to speak at the workshop. I think the first point I'd like to make is I think workshops such as these and the project is extremely important in sort of trying to move this whole field on, because it's still very early on, and we've got a long way to go, and the only way that we'll really get to all-encompassing solutions, as it's been said many times already, is by lots of interdisciplinary interaction and people working together. So having said that, I'm going to try and distill some of the findings from my PhD thesis into a 10-minute talk. So I'm going to have to rush through quite a wee bit of things, unfortunately. But having seen who's in the audience, a lot of this will be familiar to you already. So hopefully it'll be valuable. Some of it will be to some of you. The first thing I want to say is I want to acknowledge the role of the National Archives in actually bringing this work to fruition. You know, they were very forward thinking and realizing that this was going to be a problem quite a long time ago. And when they approached the University of Glasgow, we did a pilot project just to see if it was possible to actually learn a classifier to identify context-dependent sensitivities. We weren't really sure at that point whether or not it was possible. So leading on from that, they actually partly sponsored the PhD and stuff, so just wanted to acknowledge them for that. Okay, so where are we? What's the project about? Basically, as I said, firstly, we want to know whether or not we can learn a sensitivity classifier to automatically predict context-dependent sensitivities in order to be able to assist human reviewers. So you'll see right throughout the talk that the whole focus on this is actually assisting human reviewers. There's been a lot of talk so far about augmenting intelligence and providing useful information to reviewers, and that really is our objective and goal. And we want to be able to increase the speed and accuracy of manual review. So we're not taking the human out of the loop. The human is very firmly in the loop, and in fact nowadays I would say it's the computer that's in the loop, and it's actually it's still a human process. Okay, so that's our aim. I thought I'd give you a sort of brief overview of our the components that we look at, and I'll start to talk first about sensitivity classification. This is learning a sensitivity classifier when we know what sensitivities we actually want to learn to predict. The second component that we have to think about is this active learning strategies, which are how can we involve the human reviewer in the loop to learn from the human's intelligence and knowledge and feed that into a continually evolving learning system. And then most importantly, how can we actually use these models that we're learning to assist the reviewers? So how does it actually help the human reviewers? So this is an iterative process whereby we are continually learning, we're continually assisting the reviewers and learning from them. Okay, so first off, how do we go about learning a sensitivity classifier? So I dare say this is going to be quite familiar to most people in the audience. We have a human reviewer. We have some documents that we want to be able to classify, and we want to therefore learn a classifier. How do we go about doing that? So the classifier needs to see lots and lots of features of sensitive and not sensitive information. And what can those features be? They can be things like entities, as has just been mentioned. It can be parts of speech, informative terms, all different types of linguistic features. Most importantly, the classifier needs to see lots of examples, and that's where the problems come in. Not having test collections and stuff like that, and how do you learn something that you've not previously seen? Okay, so in this project, we focused on two sensitivities from the Freedom of Information Act exemptions: international relations and personal information. So when you look at these sensitivities, what we find is that they often have a similar sort of structure. So it's quite often a sensitivity will be down to who said what about whom and when. So you can see these relations starting to build up in documents, and then hopefully we can start to identify which of these relations are actually likely to be sensitive. So many of these relations share a similar semantic notion, and we want to try and use that knowledge to try and ingrain that into the classifier and learn from it. So there's been some talk already about word embeddings. In this particular work, that's exactly what we leverage to be able to actually try and learn these contexts, the context that actually makes the information sensitive. So there's a nice property with these language models or word embeddings where the position that a word appears within this sort of highly multi-dimensional space, the position that a word appears in can tell you something about the word itself. So similar words tend to group together within this space. More importantly, you can tell a relation, or you can know something about the relations between terms by the directionality of where these terms appear in the space. So there's a well-known example that's on the screen, but basically that's what we're leveraging to see if we can identify the relations that actually make sensitivities. And this is what we do. This is basically we create a representation of the document based on the terms in the document from their word embedding spaces. And when we did it, we concatenated it with a text classification approach, which is just basically a distribution of the terms, the frequency of the terms that are in the collection. Now, there's been a little bit of talk so far about deep learning models and all these new language models that are sort of being produced recently and have made great sort of progress in certain natural language processing tasks. But I'd like to highlight again the fact that we really care about transparency and interpretability at this stage. So keeping your model simple and trying to come up with simple approaches that you can interpret is very important. And if anyone's interested, I can talk about it more later on, but we've actually shown that you can actually trace approaches like this back from the prediction right to the starting point. So there is an element of interpretability if you keep the model simple. So unfortunately, I've got to rush through it a wee bit, but I'd be very happy to speak to anyone more who's interested. And obviously, we find that this actually improves our effectiveness of classifying these context-dependent sensitivities. Okay, so that was the first part. That's like we know what we want to learn. We have a test collection with identified sensitivities in it, and we want to learn to be able to predict those sensitivities. However, most collections that we will be sort of dealing with, we don't know what the sensitivities are within them. We don't know what the risks are. So we want to be able to quickly learn to identify what the particular sensitivities are within a collection. How do we do that? We use an active learning strategy. So we have a collection of documents, we want to build an active learning classifier, and we have the human reviewer, which is our main resource. We start off with an unlabeled set where we know nothing at all about the documents. We have this active learning ranker, which ranks documents by the sort of priority that they should be reviewed in order to be able to provide the classifier the most information so that we can learn a classifier more quickly. We get a reviewer to review the top K documents, annotate the terms that are actually sensitive, and then we integrate these terms into the training set. So we've now got a document level label, whether it's sensitive or not, and we've got these annotations of the particular text that makes a sensitive document sensitive. And we can start to use that to actually train the classifier. And then the iterative cycle continues until we sort of work our way through the collection. So what does this mean in practice? We've got 2 points that we really want to investigate. How do we select informative documents to get reviewed, and how can we integrate these sensitive text annotations as additional evidence? Unfortunately, I don't have time to go into all the different strategies, but I'd love to talk to anyone about it after. But here's just a very quick look at sort of what this can do for your classifying model. So the first plot is just looking at different prioritization, document prioritization strategies. On the x-axis, we have the reviewer effort, the number of documents that have been reviewed. And then on the y-axis, we've got the classification accuracy. We want to be up here in this top left-hand corner as you look at it. We want to be very quickly get an accurate classifier. So what do we look at? When we look at different types of prioritizing documents, we see margin and utility, which are approaches from the literature, which are pretty simple approaches. They work quite well to try and speed up the learning of the classifier. In the end, margin performs best, but we still haven't integrated these useful sensitive terms. What happens when we do this? We see here after 500 documents are reviewed, we've already learned a classifier which is almost as effective as the whole collection allowed us to do without these additional terms. And I shall just run through this because I suspect I'm running out of time, but most importantly, I wanted to highlight the last part specifically. This is a separate study, but we did a user study to see, by doing all this, can we actually help the reviewers? Can we actually increase the speed of review while maintaining a high accuracy in the judging? And the answer is yes. So it's a very long document, this one, but again, I'd love to speak to anyone who's interested about it. Okay, thank you very much. There's the overall framework, and I shall stop sharing my screen.